Okay, so these are exam number 2 review problems that we're going to be working on. And this particular problem is from the fall 2012 Engineering Science 2143 practice exam that we post with solutions. So let's just walk through this. We have 3 4-inch wide plates that are connected together with epoxy. Determine the required thickness of the plates to the nearest 1/8 inch if the allowable normal stress in the plates is 1/2 of the yield strength of A36 steel. Determine the required lap length for the epoxy connection to the nearest 1/2 inch if the allowable shear stress is given as, okay? So we have this connection here, and as we pull to the left and pull to the right, we could have yielding. We could have yielding of this bar. We could have yielding of this bar, and because of symmetry, they're the same. And we could have yielding of our connection. Okay, so that's going to be shear because we can see that here's the normal force. It's going to act as shear. This is going to be a normal stress and a normal stress. So we need to determine the required thickness of the plates. So when we're looking at the plates, this is normal stress, and we have thickness here and thickness here. Okay, thickness and thickness. We're using A36 steel, so our yield stress of A36 steel is 36 KSI, and we want to make sure that the allowable normal stress is 1/2 at most, so we're going to use an allowable stress of 18 KSI. Okay, so that comes from my allowable equals yield divided by 2. Okay, so let's start with, sorry, got another thing I'm doing over here. Let's start with a free body diagram. So if I'm looking at this top plate here on the left, if I am pulling 50 kips, then my internal normal has to also be equal to 50 kips. Okay? And I know that stress equals that internal normal force over A. The allowable stress we have is 18 KSI, and that equals 50 kips over area. It is 4 inches into the paper. So the cross section I need is like that. So I need into the paper 4 inches, and then I need that thickness. And when I multiply this out, okay, when I multiply this out, then I'm going to get a thickness of, let me see if I can find my calculator here. And it's attached in, hold on. Calculator. So we've got 50 divided by 4 divided by 18 equals. So I have a thickness of 0.69 inches. And then it says that we want to have it to the nearest 1/8 of an inch. So this is how I do it. That's above a 1/2 inch. So if I have a 1/2 inch, it's 0.5. So that would be the same thing as 4/8. So then 5/8 is going to be 5 divided by 8 equals 0.625. Okay, well that's just smaller, so let's look at 6/8. That's the same as a quarter, that's 0.75. So if I want this to the nearest 1/8 of an inch, I always have to round bigger. I can't round smaller. So the thickness I need for this plate, for my plate over here to the left, the thickness I'm going to need for that plate is 0.75 inches. Okay, now I've got to figure out the thickness of this member. So we're going to start, we're going to draw our free body diagram. I have P over 2, so that's going to be 25 kips. I'm going to end up pulling, I'm going to have that normal force, I'm going to use my statics and find equilibrium, that this internal normal is 25 kips. And when I'm looking at that cross section, again, it's that perpendicular cross section. It's 4 inches wide, and we're trying to determine that thickness. Okay, so our stress equals N over A. We have an allowable of 18 KSI. we have 25 kips. As my normal force, we have 4 inches, and we are trying to determine that thickness, okay? So when I do this out, I'm going to get 25 divided by 4 divided by 18 equals, I get a thickness of 0.3472 inches. And again, we have to figure out which way are we rounding. So let's look at 3/8 of an inch. Okay, 3/8 of an inch is going to be 3 divided by 8 equals 0.375. Okay, and what's just below 3/8 of an inch is 2/8, which is a quarter. And we can see that 347 is smaller than 375, but larger than 0.25. So we are going to use a thickness of 3/8 of an inch because we have to round up. Okay. And now we need to go back and we need to look at the shear portion. So determine the required, so we know that we have 4 inches, but we need to figure out this length of epoxy, okay, of the overlap to the nearest ½ inch if the allowable shear stress is given. Well, I have 2 ways of looking at this. I can either look at, I have 50 kips pulling in this direction, which means I'm going to have shear top and bottom. But I also have 2 times the area, okay? So I could look at this shear stress equals 50 over 2 times the area because we have the area on the top and the area on the bottom. So we would have 4 inches times that length. And let's go back and see what we have here. Determine the required lap length for the epoxy connection to the nearest if the allowable shear stress is. So we would use that 0.73 KSI, okay? I could also look at just the top, and when we do that, we have 25 kips pulling, which means our internal shear. If we use statics, our shear equals 25 kips. This time, we're just looking at the area associated. So again, we're going to have shear stress equals 25 divided by 4 length, and that allowable stress was 0.73 KSI. Either way, when we look at this, okay, either way, we're going to get the same answer because here it's 50 over 2, which is 25, okay? So let's go back. We have 25 divided by 4 divided by 0.73 equals, so I get that we have a length of 8.56 inches. I need to make sure that I'm going to the nearest ½ inch, so that's going to be between 8.5 and 9. We can't go down, we have to go up. So our length is going to be a 9-inch overlap. There you have it. So it's just a matter of understanding. And again, do I need to round up or down? We're just setting up those equations. So that's problem number 1.